nerd, and instead of having a mobile of, you know, stars for my son Carlitos to cry to, it's all bundled up here. I'm going to make a phylogeny mobile where I have essentially some version of this drawn out. Now, say we have species A here, species B here, species C here. What a phylogeny tells us is just how nodes are kind of related to one another. So it doesn't tell us necessarily that A is more closely related to C or that B is more closely related to C. It tells us how that A and B are more closely related to each other than C. And so, just like in a mobile, these arms can rotate any which way, phylogenies can rotate as well along their axes and tell us the exact same information. So we can imagine the mobile at some point, the fan in the room twirling this part of the phylogeny, and then you get kind of a situation like this. B, A, and C. And it's the exact same phylogeny. It still tells us that A and B are more closely related to each other than they are to C. And then the same thing, the fan can kind of spin it again, and you might have the phylogeny mobile look like this, where C is now on the left. It doesn't matter how they rotate on their axes, it's still telling us the same relative information. A and B are more closely related to each other than they are to C. Does that make sense? So if we kind of flip this back, we can think of a phylogeny as any horizontal part of the line can spin. So if you rotate this, just like in a rotisserie, you can flip this phylogeny around, but the relative positions between species is never going to change. So it's going to tell us the exact same information. So you could have, because you can spin this part of the phylogeny here, it doesn't matter if B is on top or A is on top. The phylogenies can rotate and they'll still tell us the same information. Does that make sense? Yeah. Okay. So, what's the other kind of general finding we can find from this table? So we saw which species are kind of the most close